Okay, roots of complex numbers. Gonna do a few examples. Now, let's do first example. Find the square roots of 15 plus 8i. Now, from the question, we can tell that it's going to be more than one roots. So let's start. Let square root of 15 plus 8i equals a plus ib. So complex equation there. And to find a and b, if we can find a and b, we can find the roots. So let's have a look. Now, to get rid of the square root, we need to square both sides. Now, when I do that, it'll be simply like this. So the left-hand side will be just 15 plus 8i, and the right-hand side is the square, perfect square. So it'll be a squared plus 2abi plus b squared I squared. Now, as we know, I squared is minus 1, so that will be like this, and I'm going to put them into the real part and imaginary part. So like this. Now we need to equate this together. So on the left-hand side, real part is 15 and imaginary part is 8. We do not include I here for imaginary part. It'll be just 8. So if I do that, I'll get two equations, which is a squared minus b squared equals 15, which is real part. And then 2ab equals 8 is imaginary. So we got two unknowns, which is a and b, and we got two equations. So we can solve it with it simultaneously, okay? So let's have a look. I'm going to change this one in terms of b. You can change it to a in terms of a. Doesn't really matter which way you do it. Now, the reason I've changed it, so I can substitute back in here, make it into one a terms, okay? So I'm going to do that now. So substitute 2 into 1. If I do that, I'll get a squared minus 4 over a whole thing squared equals 15. And I will get a squared minus 16 over a squared equals 15. Now, I don't want fraction here, so I'm going to times by a squared on both sides. So if I do that, I'll get a to the power of 4 minus 16 equals 15a squared. So I'm going to move the 15a squared to the left. I will get 8 to the power of 4 minus 15a squared minus 16 equals 0. Now it does look a bit like quadratic with the x being a squared. Now let's have a look and continue with this. Okay, and I'm going to factorize this. Now when I factorize this, because I can see that I can actually factorize it without any much of a problem. So the factors of 16, I'm going to have a look at it. So it's a minus 16, factors of 16 will be 1 or 16 and 2 times 8 and so on. But to get minus 15, I know 1 and 16 can do a good job on that. So I want the sum of that is minus 15. So I'm going to make that as a minus, that as a plus. So when I add them together, I'll get minus 15. When I times it together, I'll get minus 16. So that is my factors. So if I put that in, I'll get that. And therefore, it'll be a squared equals minus 1 or a squared equals 16. But I can't have a squared equals minus 1 because that'll be complex numbers. And a and b need to be real. Okay, so I had a reason for that. A and b are real. So therefore, only solution I can use is a equals plus minus 4. Now I'm going to substitute a equals plus minus 4 into the second equation, which was a b equals 4 over a. If I do that, I will get that. Okay, so when a equals 4, I will get b is I, which is 1. And then when a equals minus 4, b will be minus I, which is minus 1. So if I do that, my full solution will be the square roots of 15 plus 8i are 4 plus I and minus 4 minus I. Now, I've got to do a little bit more extra here. There's a bit more of that. If we plot the roots on the complex plane, what can we see? Now, there's the three things we need to plot them. So I'm going to do that. So let's have a look. So if I want to plot 15 plus 8i, it's simply just x coordinate will be 15 and y coordinate will be 8. But we need to know modulus, the length, and the argument, the angle. Now I'm just going to use the formula you know from the previous complex number chapter, but I'm going to give you some formula for that. So these ones are formulas, so if you don't remember, please put it somewhere and try to memorize them. So the modulus will be 15 squared plus 8 squared, which is 17. Argument is the tan theta equals b over a, which is inverse tan 8 over 15, roughly 28 degrees. Okay, so that's this one. And the next one, the first root that we found, again, the modulus will be 4 squared plus 1 squared, the whole thing square root is a root 17. And then angle, the theta argument, is roughly 14 degrees. Now this one is in the first quadrant because it's a positive and positive. Second root, same thing. It doesn't really matter with the modulus because you're going to square it anyway, so it will be the same. Now this one is 14, again same, but if you look at this is a third quadrant, negative and negative, okay, third quadrant. So we need to change that into 194 because if you think about the principal argument, it's going from minus pi to pi. So we need to change that, and it's in the third quadrant. And if I do sketch this, something like this. So my first root is 4 plus I, which is 4 and 1. And then the second root was minus 4 minus I, which is minus 4 minus 1. And the argument was 14 degrees. And of course, modulus was root 17. And this was the square root of 15 plus 8i. And its modulus was 17. And the angle is 28. If you think about this, that's 14, that's 20, it's double, okay? And then modulus is a 17, but this is a root 17. So from the observation, we can find three things here. I'm gonna do, maybe cover this one. Okay, let's think about the two of them first, okay? So, two of them, first one is the first root, 4 plus I, has half the argument of 15 plus 8i, just like I told you about. So first one was 14 degrees, but the other one was 28, so it's a half. So we can write it simply, it's a half of the argument of 15 plus 8i. And the modulus of first one, 4 plus I, which is the same as minus plus I as well, because they both were root 17. It's the square root of the 15 plus 8i. So modulus, short for mod, mod, and then 4 plus I equals square root of modulus of 15 plus 8i, because that was 17. So if you do that, it would be square root of 17, which is modulus for 4 plus I. And the third part, observation, was the two square roots of 15 plus 8i are equally spaced around origin on the complex plane, okay? And which means just half 2 pi to get pi in this case. Let's have a look at this. So from the diagram here, all that separated is just this straight line here, isn't it? And that's whole thing is 2 pi. And if I draw that, it's pi here and pi here. So they just halve 2 pi to get pi in each side in this case.